I picked up this $5 hairdryer from Goodwill, and in this 3-part series, I'm going to push it way past its limits. In this part 1 of the Teardown series, I'm cracking it open to uncover the guts, heating elements, switches, safety features, and maybe even a surprise or two. In part 2, I am dropping it in a bucket of water while it's running and plugged in to see if this cheap hairdryer actually protects you. And in part 3, if it still works, I'll stick it in a closed cardboard box and blast at full power to see if it overheats, shuts down, or goes up in flames. So let's get going on part 1. Make sure to hit that subscribe button and turn on notifications so you don't miss out on parts 2 and 3. And of course, after parts 2 and 3, if it has survived and still won't die, we'll find a way. Start thinking about how to destroy this thing and shoot me a comment. So let's go and see what's inside. All right, good day. So today in this part 1 series, we're going to be taking apart this here hairdryer that we got at the Goodwill for $5. And stay tuned for parts 2 and 3. Part 2 will be dropping it in water, and part 3 will be catching it on fire. But this one is about disassembly and testing. There's some really important testing things to do here, and it's actually more complicated than you might think. One of the things that I want to test here is this GFCI, especially if I'm going to go dunk it in a bucket of water later on. I want to make sure this thing is working properly. And GFCI stands for Ground Fault Circuit Interrupter. And what it is basically it monitors the current that is flowing up in here and coming back down out the other leg. And if I were to, let's say you were to shock yourself, or you were to get in the path of that, and the electricity started to go through your hand into your body, it should detect it and cut the circuit off. Want to make sure that that's safe, and in order to do that, we're going to use this special Klein GFCI tester that times the timing of it to tell you how quickly the GFCI reacts. And right now we've got you can see we're reading 120 volts AC across these 2 meters. So what we have is coming out of the outlet, we have an old pool GFCI. It's only rated for 10 amps, but the hairdryer one here is rated for more, and it's quite a bit smaller. So who knows how cheap they went and how cheap this hairdryer is. And so what this meter does is it times, I'm going to push the GFCI test button, and it times how quickly the GFCI will respond. And in this case, this is 0.02 seconds for this GFCI. And that is actually quite good. I believe the spec is 0.1 second or 100 milliseconds, and whereas this one was at a 0.02. Yeah, if anybody knows the actual numbers, I'm not an electrician. It would be very interesting to hear. So we're going to test this GFCI out here. We're going to crack the case open. We're going to clamp on to everything and clamp it into this meter. Hit the test button, make sure this works before we throw it in a pool of water. I do want to say before we get started here that we are dealing with electricity, and it's lethal amounts of electricity. We're adding water to it as well. A lot of people would probably say it's pretty stupid, but we're doing this for educational purposes, and I can't stress enough, do not try this on your own. I've had a lot of experience with electricity over the years. I don't want to be one of those YouTubers who dies trying to make a YouTube, so I'm going to take a lot of extra precautions. So if it seems like I'm going overboard with the safety and stuff, that's just because I want to live to make another video. But I really do think it's going to be really interesting to see what's inside of here. We're going to have to map out the switches, figure out what they do first. They're not unlabeled actually, so I find that quite interesting. So this thing is the ratings on the side of this here are 125 volts, 60 hertz, 1600 watts. So 1600 divided by 125 is 12.8. So 12.8 amps coming through this cord. And it's a 16 gauge cord. You probably can't see that. So it's kind of a thin cord. We're only at 12.8 amps for 1600 watts. So we'll start with plugging into the mains. We're going to put it on low. I'm going to turn this switch on the bottom switch here. Let's see if it's working. There's a little bit of heat coming out of there. So those are speeds. And that is heat. Okay, heat, speed. Got it. We're going to just put some temporary labels on here. Okay, fan. Heat. 3 heat settings, 2 fan speeds, and this button is just like the turbo cool. When you push it, it cuts the heat off. So I'm going to unplug it, make it safe. All right, there's no foreshadowing here, but it says don't drop this in a bucket of water. All right, so as we take it apart, we're actually not going to take this apart today. I'll probably make a series on what's inside of GFCI, just take a look at them, you know, house outlets and other outlets, but that'll be a future video. This is the hair filter. A lot of hair gets stuck in here because this is the intake. Air comes into the hairdryer this way and gets blown out here that's hot. And so this is your air intake filter. So that just unscrews. Looking at the device, I see 2 screws, 1 screw and 2 screws back here. So we'll go ahead and use that Milwaukee screwdriver that you've seen me use before. Bit doesn't feel quite right, but the number 2 doesn't fit in there either. So we'll just abuse the screw heads a little bit. Let's see how this comes apart. It's already starting to come apart at the handle, so we'll just give it a little pressure and see. So far, it's completely meeting my expectations. This is a really cheap piece of plastic here, which is interesting. Okay, we are unplugged, so I'll drop the main cord away. So let's take a look. So I find it interesting that right off the power cord, it comes into the fan. So, oh yeah, this is the actual on switch for all the power. So, comes in from the mains. I see that one of the leads goes right here into the fan switch, and then from the fan switch it goes out. So this thing won't actually turn on the heat unless it's already turned on through the fan. And I see the fan switch here. I also see something here which is really kind of crazy, but this is really cheap wiring where these wires are rubbing against other contacts in here. So not a very safe design, but at least if you turn the unit off, it should be de-energized the rest of the way. And then the neutral wire runs down in here somewhere too. And I can't quite see where the neutral's running yet. I'll have to take a look at that as well. So this is the main here. Got to find the neutral so that we can clamp onto that. So one set of power goes up into here, which is probably the fan. Oh, another one goes into here, which is also the fan. I might have to draw a picture of this circuit because I really don't know. Yeah, these just are pressure held in. Yep, all the switches are just pressure held in. And that's just a retainer clip, so we'll see what we want to do with that in a few minutes. I want to see where that neutral goes. The neutral actually goes here. So it's kind of a weird design. Like you've got the hot, so you have the wire coming in here. The hot wire, black should be hot in this case. We can try to test that. It'll be a little hard with the GFCI, but we'll see what we come up with. And then the neutral comes up to this fan switch. Yeah, that's just a really bizarro design where you've got 3 legs on here. You've got 3 different speeds that you could turn it on to, which is heat settings right on top of the fan. So very interesting there. So we're going to just pull that out just a little bit like this. All right, before I explain this, quick test. This is my non-contact circuit tester. You can see there's live voltage going up to the lamp there. But if we come down here on this side we've got current, there's a switch here, and we got nothing into here. And we also confirm that with our meters. So the setup we have is this. We come in with AC voltage, we split it off, 2 test leads go to the Fluke just for voltage measurement. I don't know, just because it's cool. Don't actually need that one. The other lead here, which is this GFCI, gets plugged into the actual hairdryer here. But notice that the hairdryer is in pieces. So when we energize it, this will become hot. This is the neutral, but these will be live leads in here, and we've just clamped onto them. So that's part of it. And then in order to actually do the GFCI test, we have this cord here clamped, this cord that goes to the Klein tester. We have this cord here, and it's clamped onto the hairdryer. The black is the neutral in this case. I know it's a little bit backwards, but I had a red one, and the red one is the hot one coming in, which is the hot lead, which should be energized once we turn it on. And then we had to connect a ground. We needed ground so that when this meter, you hit the test button, it has a place to dump the current that's not in the standard path. And then we're going to test how fast this thing trips off, how well it works, and if potentially it could help you. Now I know GFCIs don't save you in every situation, so just be aware of that. All right, so we're ready to go. I am actually very intentionally hand holding my camera because it'll force me to only use one hand. That is actually a safety method. And I've got some good rubber shoes and a mat underneath me. So here we go. We're going to walk over here away from everything. We're going to turn on the power. Again, don't try this at home, but you can see we've got 120 volts. So those leads are now live. Everything here is super live. So what we're going to do is we're going to reach over to our GFCI tester, and we're going to hit the button and see how fast it responds. That was quite loud for the GFCI, but you can see it responds in 0.20 seconds. So fantastic. So we know that little GFCI works, and we'll probably take one apart in a different video somewhere. But for now, I'm going to de-energize, take this apart, and we'll just start getting into completely ripping that apart. So as you can see, everything is de-energized now. As I'm looking here, the fan, if you can see in there, there's the screw here and a screw here. So we're just going to take those screws out. I'm going to use a hand screwdriver just because it's a little longer for the handle. It's actually, I'm using a number 1, but it's actually a number 2 screw that goes in there. It's held in there. Okay, there's one screw. These are different sizes, so I'll just make a short note of that. These are the larger screws. We do want to make this thing work when we're done. All right, so let's go ahead and take a look inside. So we got the fan here. We have a button that controls the fan speed, low, super high. We have a switch here that has 3 different heat settings, and I am losing a little button there. That's just the heat cutoff, so it can just continue to blast air. And let's go ahead and take a look inside and see what we've got. So this is what's inside a hairdryer. So we'll come back to the coils, the heating coils, in one second here. I just want to point out that inside of this, there's this heat-resistant paper that's just taped, literally taped to the inside of the cone. So when these heat coils here are producing heat, it doesn't melt the plastic. I mean, it's incredibly cheap. So you have this fan attached to a motor in here, and it spins at 2 different speeds, slower and faster. It blows air over these heating coils. These heating coils have, 1,500 watts, which is a lot of power going through them. So the fan actually, if the fan weren't running, this thing would just self-implode with heat anyway, because there's no place for all that heat to go. It's basically a space heater in a tube in terms of the amount of power it puts out. And then we'll take a look at the switch here in a second, but the motor is right here. And you can see the motor has little holes in it, probably cooling holes or something else. These are really super cheap ones. So when I go ahead and dunk this thing is probably never going to work again, but we'll try to blow it out with a compressor and get that working in the part 2 here. I see a diode here. We see different configurations of heat coils. They have different like little tabs to start them in different places. Like this heat coil starts here. So I bet there's like a bottom. There's like setting 1 is like these heat coils. Setting 2, the hot, is these heat coils and these heat coils. And maybe setting 1 is just air coming through. Let's see, this is interesting because they've got this kind of heavy duty foil like paper thing, and I think it's conductive. I think this whole thing is supposed to be some sort of conductive plane where they attach stuff to. It's like the ground plane here. Because you can see there's the diode that comes off of the fan speed. So one of this fan speeds hits this diode right here and then comes through the diode and gets soldered in to this yellow wire, which then goes all the way back here. Like, none of this makes sense to me from a wiring standpoint. So try not to hit too much on the wiring right now. We could make a part 4 where we dissect the diagram and figure that out, but for right now we're not going to do that. So diode, what else do I see in here other than the coils? I'm glad this thing wasn't full of hair, by the way. So it's just, when I bought it I was like, oh, here's a used hair dryer. I can only imagine what's inside. Very lightly used, so I was actually lucked out here. There's a thermal fuse under here, so if this fuse gets too hot it blows, and then the unit is no good and you throw it away. It's not serviceable and it doesn't self-reset. I'd be pretty sure about that. But there's also another device right here, if you can see it. It looks like this is probably a self-resetting thermal fuse. So this one's probably set to, like, well, I'll make a number up, but we'll just say like 200 degrees Fahrenheit. And if this hits 200 degrees, it trips, cuts the power off, and then the fan stops. Everything just, it cuts all power to the unit, right, internally. So that's one size, and when it cools down, it resets, and then it's back into business. And then this one's probably set at like 250, 300 degrees, and if it blows, it means there's something catastrophic happens. It means that this didn't work. So this is the final safety, and then it cuts power to the heating elements and the fan and everything, and the unit just dies, and you end up throwing it out. So that's what's inside a hairdryer. Some switches to control things. I call it bizarro wiring. It's always probably the most efficient and cheap way to make it, but to me it's just kind of bizarro wiring, where you have these super thin wires coming in, they come off to switches, they do various things, they turn different coils on, but it's not like this wire turns coil A on and this wire turns coil B on directly. It goes through a whole bunch of stuff along the way to do it. So that's it. Pretty simple. I can see why you can buy these at Wally World brand new for $11, $12. They have a really low budget item. They definitely don't have a lot in them. Okay, I'm just gonna put this unit back together in preparation for the dunking. I wanna make sure I get it back together kind of the way it came apart. I see a couple places where the wires, I should have paid more attention when I took it apart, but you know, it's always exciting to take these things apart. So let me get the screws back in. Gonna pre-start it a little bit, make my life easy. As I reassemble this in fast motion here, make sure to subscribe to my channel. That way you'll get the updates for parts 2 and 3. And I really do hope that you are getting some value out of this. I'm trying my best to make real content. It's not always sensational. I think we live in a world where everything feels like it has to be sensational content to be good content. I have some favorite channels that I watch that kind of take this approach here. I appreciate everybody viewing. It's been outstanding. I've had way more viewers than I expected. And just thank you, and thank you to everybody watching. Okay, there we have it, back together. Some of those wires were kind of tricky to get through there. That yellow one in particular is super short. So in the factory, I'm sure they were just like, oh, we're not going to send this back. But everything appears to be working. We're going to plug it in real quick, give it a quick check. Back together. We're going to do the final check here. We're going to plug it in. Going to make sure it still functions there. Should we take that apart today? Oh, let's put this on. It is energized. Okay, so still functioning, which is great. I have the fan set to 1 and the heat set to 1. Can't really tell if there's any heat coming out of there. Definitely on 2, we've got some heat. It's heat setting 2. We'll put it to heat setting 3 here. It's definitely hot. Okay, that's a wrap. That is what is inside a hairdryer. Next up, we'll be dunking this hairdryer into an orange bucket full of water with a ground lead attached to the outside. Make sure to subscribe so that you are notified of that next installment so you don't miss it. And we'll see what happens when we drop a hairdryer plugged in and running into a vat of water as if it were the bathtub. Do the safeties work and what happens. So make sure to like and subscribe, and thanks for watching, and I hope you learned something.